Welcome back to the Scotti-BYTE channel, and this is Scott. So in Houston, Texas, where I live, we have this not so affectionate name for our power company, and we call it sometimes Houston Spark and Flash. And this is particularly hostile if you run a home lab type of environment. So about 2 years ago, I covered this software that is called the Network UPS Tools, or NUT tools, and it's used to manage and monitor your UPS systems. And I remember a while back somebody asked me, well, what should I put a UPS in front of? And my answer was anything that you care about. And so here I have a whole series of UPS systems. I've got 5 throughout the house. And probably the most critical, of course, is the one that is in the computer rack. And I can click on these things with the Network UPS tools, and I can see a graph about their basic performance and what they're doing. And then likewise, I have one for my desk side UPS also in my home lab, and then one here in my office, and then I have one in my family room and one in my bedroom. And you might ask, why do you have one in your family room and bedroom? And the answer to that is because I have TVs in there, and behind those TVs, since they're expensive, I have UPS systems that condition the power and also provide battery backup to ride through these various interruptions in power, hence spark and flash. So how do I run this particular piece of software to monitor these UPS systems? And when you have one behind a computer, that's really simple. You just connect the USB cable between the UPS system and the computer, and you load the appropriate UPS monitoring software. But if you have something like this family room configuration or this bedroom configuration, you normally don't have a computer in there. And what I've done in those instances is I took some old Raspberry Pis, Raspberry Pi 3Bs in the case of the family room and bedroom UPS systems, and I went ahead and connected them via the USB cable back to the UPS units in those particular locations, and then running the NUT monitoring software. So about 2 years ago, I did a presentation that was entitled QNAP, UPS, and More. And although it wasn't specifically about the QNAP NAS UPS function, that was something that we did cover quite a bit. And we did cover exactly how you configure that software to perform the connection. So what exactly is that software? Well, that's this thing called the Network UPS Tools. And Network UPS Tools has been around for many years, and it's basically software that is designed to run on a particular computer and then be able to monitor the attached UPS, or the second thing that it does is it can run on a computer without an attached UPS, and it can monitor what is happening with the UPS running elsewhere on another system, and then decide whether or not it needs to perform an orderly shutdown. And so the Network UPS tools can actually be set up to follow the activity that is occurring on another system that is directly connected to a UPS unit. And in the event that there's a power failure and that other system detects a power failure, this remote system not connected to a UPS can perform an orderly shutdown. So in this tutorial, we're going to have to configure the Network UPS tools on the systems that we want to monitor. And just for the purposes of this tutorial, we're going to assume that that system is directly connected to a UPS. And what I want to discuss today is specifically this software called PeaNUT. And so the idea behind it is basically the network UPS tools. And this particular software is rapidly being developed. It's at version 5.19.2, and there was just a modification to it 2 days ago on December the 6th, 2025. If I scroll down the page here, it is showing you a copy of what the dashboard looks like and what some of the graphs look like and what some of the capability of the software is. In addition to just being software that monitors your UPS system, this software can also be connected to other things, like it can be connected to an influx database, and then it can display the data in the database on a Grafana dashboard. Just in terms of limiting the scope, I'm going to consider the configuration of influx database and the Grafana dashboard to be out of the scope of this particular video. Since I covered NetMon that you see here about 2 years ago, I'm not going to review it, but instead I'm just going to focus on PeaNUT, and here's my installation of PeaNUT that you see here. So there are my 5 UPS units that we looked at a little bit earlier. We have the office UPS that I'm sitting here with my main computer connected to it. And then I have a 2 QNAPs, that is QNAP NASs, that are running the UPS software also. And they're my rack UPS and my desk side UPS in my data center. And then here's the family room UPS and the bedroom UPS. So what PeaNUT does is it tells you the status of your UPS, whether it's online or not. It tells you the current battery charge, and it also tells you the current load on that UPS. Now, if I go ahead and click on details, it will bring up a graph. And in this case, it's showing that the load on my office UPS here is 16%. The battery charge is 100%. And then theoretically, my battery time would be 1 hour and 24 seconds. I find that a little hard to believe. A lot of times those estimates are inflated. And then if you run the software for long enough, and I haven't run it for long enough, it will start to produce some data points here, and it will show you things like your voltage. If we scroll down a little bit further, we can see all of the raw UPS data values that come back from the UPS, which we'll look at during the course of configuring the software. Now, if I come back up here, there's a very small section here where it says actions, and it gives me the ability to do some testing. So I can go off and do a quick test or a deep test of that particular UPS unit. The other thing that I can do here is I can control the power, where I can decide to either restart or shut down that UPS unit. And then the other thing we have here is the control over the alarms. I can turn the beeper on or off, or I can mute the beeper. And if you're familiar with that, it's when your power goes out, your UPS typically will start beeping. Before we can monitor a UPS, we have to have software on that UPS in order to monitor it. And so that software is going to be the network UPS utilities that I spoke about earlier. And so I'm going to SSH over to my bedroom Pi, which is a Raspberry Pi 3B. And that Raspberry Pi 3B has one of its USB ports plugged into the USB port on the UPS unit that it is connected to. So the first step that you want to do, and I'm assuming that you have some kind of a computer like a Raspberry Pi, or you have installed a Raspberry Pi in order to do this operation, and Raspberry Pis are inexpensive, which is why I mentioned them. And in fact, this Raspberry Pi 3B only has 1 gig of memory, and so it is a very inexpensive computer. So your first step is you're going to want to do a sudo apt install of NUT. And so I already have the NUT software installed on this machine because it is already set up to do the monitoring that we're going to look at here. So then I want to do a cd over to /etc/NUT. And then over here, I want to do an ls/usb, and ls/usb is a command that will list anything connected to your USB bus. And as you can see here, on bus 1, device 5, I have an APC UPS unit, and there it is. So that ls/usb command is important to verify that is where your device is connected. If you don't see it, you want to make sure that your cable is connected from your USB port on your computer to the USB port on the UPS device. And so here, when we did the ls/usb command, this first number here is referred to as the vendor ID, and the second number here is referred to as the product ID. The vendor ID and the product ID in Linux are the two things that you need to identify anything that is on a USB bus. One of the great things that the NUT software does is it provides this command called the NUT scanner. So here I'm doing a sudo nut-scanner -u to see the connected UPS units, and there it reads them out. So nutdev1 is just an arbitrary name it gave to this UPS device. We're going to change that later, and the driver is USB HID-UPS, which is pretty much universal amongst any USB connected UPS unit. Here we have our vendor ID that we got from the ls/usb command, and we have our product ID that we also got from the ls/usb command. And then it has a product name, which many times is optional, a serial number, which can be optional, and then the vendor type. And then here it has a bus number, a device number, and a bus port. And then it has a comment here at the bottom of that. So I took the information from the NUT scanner here, and I'm editing a file called ups.conf. And I have to go off and do a sudo nano on that file, since these files are owned by root and I'm logged into my user account. So here I go in and I arbitrarily decided to call this thing bedroom UPS, so I had a user-friendly name associated with it. You'll notice at the top I added poll interview equal to 1, or poll interval equal to 1, and max retry equal to 3. And those are useful parameters for timing purposes. The port is set to auto, and I have the bedroom UPS is the human-friendly description of this UPS device, and there's the vendor ID and the product ID. And from experience, I found out that this is usually the minimum that is required to configure any UPS. Now that we configured the UPS, the next thing that we want to do is configure the NUT configuration file. And when we go into that particular file, we're only going to put one command in there, and it is mode equals net server. It has other values like mode equals standalone, but the reason we're making it equal to net server is the whole purpose of having the software is so that remote systems can contact it, and net server allows for that. So I'm going to go ahead and exit that file. The next thing we need to configure is the UPS monitor file, and I'm doing a sudo nano upsmon.conf, and this file has only 2 lines, and this one is going to be important in terms of saying which UPS, that is the UPS name that we specified earlier, and then I'm giving a username and a password. And then the word primary is just one that we want out there because it is part of the syntax. So this is important because this has to align with another file that we're going to edit shortly. And so we have to set up that username and password. And if I do a sudo nano upsd.users, we go into this file here, which will have typically a whole bunch of comments. And by the way, this is a good time to point out that you can erase anything that happens to be in those previous files and just put in the things that I mentioned here. So I have 2 users I created here just as an example. One is called monuser, and it says password equals 123456, and the other is just upsmon primary here. So that is the UPS user, mon user, and then the user for the purposes of this video is one called PeaNUT. And then PeaNUT has a password of PeaNUT pass, and then the UPS mon is a master. And then we have instant commands equals all, and we'll get into what that is in a little bit as well. So I'll go ahead and exit this. So we just edited upsd.users, and the last file we need to edit is something called upsd.conf. In this file, we really only have 2 lines. The first line tells it to listen to any connection from anywhere coming over IPv4, that is anywhere on my local area network in my home lab. And the second one is the same listen command except for IPv6. So I'll go ahead and exit that file as well. When I edited that user file, one of the things that I mentioned were those instant commands, and the instant commands can perform things like battery test, turning off the UPS load, restarting the UPS, calibrating your battery if your UPS unit supports that, shutting down particular UPS outlets, again, if your unit supports that, and then enabling and disabling the beeper as I showed you in the demo for the PeaNUT software. So now that we have all of our configuration files in place, in order to make them take effect, we're going to restart the NUT-server with sudo systemctl restart NUT-server. And then we're going to go ahead and perform a sudo systemctl restart NUT-monitor. And to make sure when my Raspberry Pi reboots that these services are going to start automatically, I'll do a sudo systemctl enable NUT-server, and it goes ahead and says that it is enabling the service for restart, and then the same thing for NUT-monitor with the sudo systemctl enable NUT-monitor. And now that I have those services enabled, it's possible for me to go off and test and see whether or not our NUT service is working. And so the command UPSC and the name of my UPS, which is simply bedroom UPS, and then I said at localhost, is the command. And when I hit it, we can get a long listing of all of the parameters back from that UPS. It's giving me battery charge and giving me other types of things as I look down the list here. So now our UPS client on our Raspberry Pi, which is connected to the UPS unit in the bedroom, is operational with the NUT monitoring software. I've just logged into my demo-1 Incus server, and now I want to go off and create a container to run the PeaNUT software. And so if you're familiar with my channel, you're familiar with creating Incus containers, and if not, go over and watch my video entitled Incus Containers Step by Step. Here I'm doing an Incus launch, images, Ubuntu 2404. I'm calling the name of the container PeaNUT, and then I'm using the default profile and also the bridge profile to bridge this to an address on our main LAN, as I discussed in Incus Containers Step by Step. I'm setting boot.autostart equals to true, which means that any time that the Incus server boots, this container starts as well. And finally, I'm setting security.nesting equals to true, which means that it allows me to nest a Docker container inside this Incus container. And since PeaNUT is a Docker application, we need that nesting parameter. Let's connect to our newly created container with an Incus shell into the PeaNUT container. And now the first thing that you want to do anytime you create a new container is to update the repositories and also to install any pending updates. And we do that with an apt update & apt upgrade, and we put a -y at the end so that it won't prompt us. And normally containers, when they're created, are usually completely updated, but this is just a good step. And as you can see here, our container is completely up to date. I have a few dependencies that I want to install into this container, and I'm going to do so with an apt install curl, nano editor, net-tools, the OpenSSH-server, and OpenSSL, and I'm putting a -y at the end so that it does not prompt me for the installation of these packages, but just continues. Since PeaNUT is a Docker application, we're also going to install Docker from the script on the Docker website. Now that Docker's installed, I'm going to add myself a username with an add user Scott. I'm going to give my Scott account a password, and I'll verify that password. Now that I've done that, I want to go ahead and put Scott into the sudo group for management purposes. And so I'll do a usermod -a G sudo Scott. And then I'm going to also put Scott in the Docker group so that I don't have to use sudo to execute Docker commands. Now we're going to do an su-space Scott, and that will go ahead and log me into the Scott account. Now I'm going to go ahead and do a make dir on PeaNUT, and then I'm going to cd into the PeaNUT folder, and then I'm going to execute the command openssl rand-base6432, and what that's doing is it is going to create me a secret for my web authorization. Let's go ahead and copy this web token that we've gotten here, making sure we've gotten everything including the equal sign. And then I'm going to do a nano on the compose.yml file. Let's paste in the code for my Docker Compose file here, And this is really pretty simple. We only have one service, and that is PeaNUT. There's the image for the PeaNUT file, and then there's the name of the container, and then we have the restart unless stopped, and then we have one folder, which is the configuration folder for persistence. I have the web port set up as 80, and consequently I'm exposing port 80. And the reason for this is because I know this port is unused because we're inside of a dedicated Incus container, so all ports are available for us. And then we have the web username and we have the web password, which is change me without the E. I'm going to change that to a very sophisticated and hard to guess password, which I will make password. Yours should probably be something slightly different. The next step we have is to erase the secret and to paste in the contents of what we got from the OpenSSL command. And so now I'm pasting that in here, and we are now done with this. So I can do a Control-O and enter to write the file out, and a Control-X to exit the nano editor. We can now launch our program with a Docker Compose up-D, and it will go ahead and pull down all of the overlays necessary for the PeaNUT container and create the container and start the application. Now that the application is started, I'm going to go ahead and do a Docker PS just to make sure it's running okay. And the thing we're looking for is that it says that it is healthy. And next thing I can do is a Docker Compose logs just to see what it's doing and how it's doing it. And it basically says that it is up and running, and all I need to go to is the local address. If I do an if config command and I look for ETH0 in my container, it's using this address, which I'll go ahead and copy here. I'll bring my web browser back up, and in my web browser I'll come over here and enter that address. When I hit enter, I will get a username and a password. I'm going to type in admin and then my super secret password, which is password. And then it says something went wrong. Let me go try to type that in again just to see if I can get this right. And it still says something went wrong, and hence live video. So it looks like we have password. I see it wiped out my admin up here. So we have to put admin, and we have password in here, and now I should be able to log in. And sure enough, it does. And then of course it says the password you just found is in a data breach. This is Google responding, not the application. I guess that Google doesn't like passwords called password. And this prompt says that no devices are found. Add a new device in settings. So if we come up here to the gear, it'll say that it wants you to manage servers. I hit the plus sign here, and the server address that we are going to put in will be the address of that bedroom Pi, and it is 172.16.1.160. The port number for all the NUT services is normally 3493, and then my username for that bedroom Pi is actually, or the configuration of the NUT in the bedroom Pi, I should say, is PeaNUT, and then I made the password PeaNUT pass. And so let's just check and make sure that that's correct, and it should be. And I did not want to bring up Bitwarden, I wanted to expose the password. So sure enough, PeaNUT pass. And I do an apply, and it says changes are saved. So the next thing I can do is go to this three-dot menu here and say test the connection, and it says the connection is successful. The other options we have down here are for the influx database. This program does give you the ability to add a container for an influx database, and that way you can persistently store historical data about the performance of your various UPS units. I didn't do that because if I went in and did that, this video would be hours and hours long, because not only would we have to configure the influx database, but we would also have to configure a Grafana dashboard to display that information to make it useful. And then they have an import-export configuration, which is importing and exporting the configuration information for your UPS units. They have a terminal, and as close as I can see, this is a terminal that is designed to allow you to talk directly to your UPS units. And then they have a section called General, and that simply has things like your date and time and your temperature units, which you can change from Celsius to Fahrenheit. We can click Apply, and then we have the dashboard here, and it will give other types of information. If I come up here to where it says PeaNUT with the picture of the PeaNUT and click on it, it will come back up and it says there is my bedroom UPS unit, which you can see is currently at 5% load because the television connected to it is powered off, and that's what the television uses in its low power mode. I can go here and click on details, and sure enough, that will give me the graphics that we saw in the introduction. And we have our menu up here where I can control the beeper, because apparently this UPS unit doesn't provide any of those other more advanced functions. And I can scroll down the screen and see all of the detail on that particular UPS unit that we saw with the UPS-C command that we did interactively when we were logged into the Raspberry Pi. To head back up to the dashboard, you simply click on the PeaNUT up here, and we could go over to the gear again, and we could add more servers by simply clicking the plus sign. So I think that PeaNUT is a nice, modern, relevant, and apparently frequently updated piece of software that will really be great in your home lab. Anyway, that's it for today. Please subscribe and like to the channel, and don't forget to hit your notification bell, and we'll see you next time.